Okay, welcome to the expose of the Conduit Canon. I'd like to explain first some of the raw materials we have here. The coils, 331 coil solenoid here. The wire was obtained from an old Volvo starter motor assembly. And have a simulated capacitor bank over here, which consists of a car battery and a relay and a timer switch, so that we can turn the speed of the current and voltage up or down in time, and a trigger switch here. Hewlett-Packard 3561. We have some conduit, plastic conduit there. That's in our for our calibration tube to be able to calibrate our projectile, which is also made of steel conduit. It's made of steel conduit and has two disc magnets in it to allow us to see its passing. The Canon will work without the disc magnets, but the magnets allow you to measure the velocity with the Faraday velocimeter on there. Okay, so we also have a Allegro 1302 chip here that senses magnetic fields. These disc magnets are kind of interesting. You can see the chip here is kind of an ambient magnetism. It puts out 2.5 volts. We built a little voltage regulator over there for it, and you can see what happens when you go around the disc magnet. It goes plus for north pole and not negative for south poles. So you can see that the magnet itself is actually magnetized around. It's got a north and a south pole around the perimeter of the magnet, which is kind of interesting. It makes it a little bit tricky when you go to assemble the projectile to get kind of a uniform field on there. Okay, I'd like to check out the projectile magnetism to show you what's going to happen a little later here when we go to calibrate this. Watching the scope there, you can see what happens. I moved the discometer there, and you got 1, 2, and a small one, but that's just because of my incompetence here, blips on the screen. Alright, in order to calibrate the projectile, we've got this tube set up here. Obviously it's a known distance from the top of the tube down, so we calculate the velocity of this thing. And using these Faraday velocimeters here, we can see how far it is between these magnets, how far they actually act. So I just put it in the top of the tube here, let it go, and you get a similar shape to what you saw over there when I swept it with the Gauss meter there. So using that, drum roll, we're going to calculate, we're going to measure the velocity of the projectile coming out of the Conduit Canyon. So here's our velocimeter here, and here's the Canon getting ready to fire. Go over here. Okay, load up the Conduit Canon there, and flip the switch. And you can see this is the relay turning on, relay turning off, and you can see the projectile going by the Faraday velocimeter there, and you get the 2 bumps. So the distance between these 2 bumps will allow you to calculate the velocity of the projectile going out of there. Now, one thing I wanted to demonstrate here, there's a lot of things going on inside that solenoid. If you turn the timer up a little bit so that it doesn't turn off, instead of, it'll never get out of there because Mr. Ampere takes over there and holds it in. So there you have it.